Let's for a minute take a detour from the JavaScript course and talk about source control. Remember when I initially put in the syllabus for this course, I said that I would talk about source control. I think it is high time we talked about source control. If you are new to the world of writing software as a profession, you might not have heard about source control. It is also possible that you do know about source control, but you have never used it. Let me introduce you to one of the greatest tools that is used in software industry that is usually not taught in schools and colleges. This tool is called source control. Conceptually, it is easy to understand what source control is all about. Let me start with an example. If you have written any non-trivial amount of code without the use of source control, the way it is done is the following. You wrote a piece of code and then got it to a state where it is working reasonably well for you, and you just finished fixing or implementing some major functionality. So here on the screen you can see in the box that I just drew, you are quite happy because you wrote your program.js file, it works, and you are quite ecstatic. Now you want to make some more changes to the code, but you want to make sure that if you make a mistake, you screw something up, you can always go back to the state where the code was still working. The way most people do this is by creating a backup file or directory. So if you're working on program.js, you would usually copy this file to program.js.back. A little while later, you are in the same situation and you need to create another backup, so you copy this new file to program.js.back1. This continues on, and pretty soon you have a directory filled with backup files. So here in this illustration here, you can see you created this program.js. This is your latest version that you're working on, but this is broken. It's a bad copy, doesn't work. And before that you had created backup 5, backup 4 here, backup 3, backup 2, backup 1, and then these two other names. Now you are not really sure which one to go back to. Now you are equally not sure whether you broke it just with the latest change or a change that you made about, I don't know, say 5 backups ago. How would you want to go back, or how would you go back to the last properly working version? Which among the last, backup 1, backup 2, backup 3 is the right version to go to? So you start ripping your hair out and start thinking, oh, if only there was a way to get rid of this insanity and do this in a more meaningful manner. Enter source control. This is exactly the problem that source control tries to solve. The way source control works is that it allows you to create snapshots of your code at various points in time. You don't need to keep creating the backup files or directories. You keep editing your code, and whenever you feel that you need to create a snapshot of your existing code, you use source control to do that. Source control asks you to enter a message for each snapshot that you create. Source control additionally notes down only the changes that you made from the previous version of the files to the new version of the files. It additionally shows you the history of one or more files or even directories in terms of how many changes were made. It can show you the exact changes you made to a particular file whenever you created a snapshot. So effectively, having source control creating snapshots is like having really great memory. You would never have to scratch your head and think, I wonder when I made that change, or what exact changes did I make. Source control can tell you that. Since source control can keep track of all the snapshots, it allows you to jump back to any of the snapshots and you can start working from there. If you just made some changes and want to go back to the pre-change state, source control can do that. So here on the screen, as you can see, this is how source control sort of looks like at a very high level. The red box here is what a source control system would look like. You have an original copy, the first version that you checked in, that you put into the system. Then you made some changes and asked the source control system to note down those changes. So the source control system notes them as change 1. Then you make another change and tell source control to save those changes. Source control notes them down as change 2. Each time you make a change, the source control keeps on changing source control keeps on saving those changes. So you see here you have the original, then the change 1, then change 2, then change 3, and all the way up to change n. You can go back to any of these changes at any point of time. You can go back and go back to version number n, version number 3, version number 2, and so on and so forth. If we look at the details a little bit of how source control looks like, usually one single change in source control looks like the following. Whatever I'm showing you within the box, that is how one source control change looks like. Each change has a number, an ID saying what number it is. And then it also contains things like who made that change. So in this case, you can see that Sanjeev made the change. It also notes down what date the change was made on, or why the change was made, because every time you put in a change through source control system, you have to enter a message. So here Sanjeev said it was not working. That's why they did it. And then the most important part, it also contains the exact details of all the files that were changed. So it contains here a listing of file1.js was changed, file2.js was changed, or broken html.html was changed. If you want further details, source control can give you the detail for each of these files. So here we see file1.js had one change, and here you can see that the red portion is the portion that was changed. So source control can give you the details saying the black portion of the files were untouched, only the red portions was changed. So this is quite powerful. Given all these capabilities, one would think that source control would be one of the first things that you would learn in college. Unfortunately, the first time most software developers use source control is when they enter a company. Personally, I firmly believe that using source control can help you write code more effectively, and hence this lesson. Now, before I start explaining how to use source control using Git, which is an open source source control system, here is some terminology. Number 1, a repository. When you start using source control, the way source control works is by placing a copy of your source code in a location different from where you are making all the changes. This location is called repository. The reason for using a different location is that source control can now track all your changes in a central location away from where you are working. So in this diagram here, you can see that there is this location called repository. It contains a copy of all the 4 files that you also have in a different location. The second terminology is called working copy. After you put your code in a repository, to start editing the code, you need to take a copy of the code out of the repository. This copy, which you took out of the repository and are currently working on, is called as the working copy. So here on the right hand side, we have a working copy. First we create the repository, then we create the working copy out of it. Now checkout is the process of taking a copy out of the code of repository to modify. So here you have the repository and you have the working copy. The way you create a working copy out of a repository is through a process called checkout. Then next is check-in. After you have made some changes in the working copy and are quite happy with them, you will want to submit them as a snapshot in the repository. This process of putting code back into the repository is called as a check-in or a commit. So you have the repository, you checked out a copy called the working copy, you made whatever changes you deemed here, and then you check back your changes into the repository. This process is called checking back, check-in, or committing. Usually when you check in something, you have to supply a message at this point saying what the changes are for. It is a good idea to put in a descriptive message so that at a later point of time, if you want to figure out why you made a change, you can just read the message and understand it. The last terminology here is called def. Before you make any check-in or commit to the source control, it is usually a good idea to look at all the changes you have made in a clear and concise manner. Source control tools usually come with a built-in tool to show these changes in a nice visual manner. The process of looking at the differences between what is in the repository and the working copy is called as a def. To use the Git source control, you should obtain a copy of the Git tool from internet. You can download a copy of the Git Source Control system from msysgit.github.com. If you look at the browser here, the URL is actually highlighted here. You go there and you click on downloads, and then you can pick whatever the latest version is for your platform and install this. The msysgit tool is a command line only tool, so if you are like me, you would prefer to use a graphical user interface for this. The graphical user interface for Git is called Tortoise Git on Windows. So to get Tortoise Git, go to bing.com and search for Tortoise Git. The first link that comes up is the right one. Click on it, and then it takes you to a web page. And here you can see that this link that just got highlighted right at the top is the one that you need to click. Click on this, and it will take you to the download page. You have both the 32 and the 64-bit versions available here. Download it, both for msysgit and Tortoise Git. Just keep on, run the installer and keep on hitting next until you hit the end, and that would install both Tortoise Git as well as msysgit. Now, once you have installed both the msysgit and Tortoise Git, you should reboot your system once for all the changes to take effect. Once you are ready, after rebooting, you can continue on. So here you can see that in my computer, the file explorer, I am in the C:code directory. Here, if I right click, I will have these extra menus added to my right click menus. So the first one says git clone, then there is git create repository here, and then there's Tortoise Git, which is right now shows another three menus, sub menus. So the first thing that we do is we will create a repository here. The way to do that is right click and then scroll all the way down and click git create repository here. That will bring up this dialog called git init Tortoise Git, and there's an option saying make it bare and so on. Right now don't select it, we'll come back at that later point of time, but say OK. And it says initialized empty git repository in C:/.git. So you can see the .C:/code and then this little .git at the end. What it has done is it has created a directory within this directory, and its name is .git, and it's a hidden directory, so you can't really see it. That's where it will keep all the repository. Hit OK. Now let's say I want to add a file here, so I will right click and say new, and then let me say text document, and I will call it git test. Open it, and let's put it in here. This is a git test, right? So, and let's save it. File, save. Close this thing. Now we want to add this file to the repository so that any changes we make to this file are tracked by the source control system. Right click on this, and let's say now when you right click and select Tortoise Git at this point of time, after you have created a repository here, it will show additional menus. Here we see this add, so we'll hit on the add, and it will bring up this dialog and show that this file is not versioned. Click on the select all. Once it has been selected, say OK. So after it will say add finished, and then it will give you the option of commit. Remember, we talked about commit, which is checking in files to the source control system. So at this point of time, we just made changes to the file and we want it to be fully added to the repository, so we will hit the commit button. So hit the commit button, and it will bring up a dialog saying username and email must be set before commit. Do you want to set these now? What it is asking is, remember how we talked about whenever you check in code or whenever you commit code, the source control system needs to know who did it and why they did it. So this is Tortoise Git asking the who part of it. So let's say yes, we want to set these things. Then it brings up another window which will ask for your name. So let me put my name here, and Sanjeev D at Microsoft.com. Hit apply and say OK. Now it brings up the dialog saying put in a message saying why you are checking this. So let's say this is I am testing Git. This is my first check-in, and I say okay. At this point of time, it says it has committed. It says root commit, which means it has committed, and it says one file has been changed, one change has been made, so it shows one insertion. We say okay, done, close. Now you see it shows a little green check mark next to the file. This means that this file has now successfully been added to the source control system, and right now there are no uncommitted changes. All changes have been submitted to the repository. Now let's open the file one more time and make some changes to it. So double click it and it will open up. So I said this is a git test. Now let's put in another change here saying this is yet another git change. Save the file, save, and then close it. And you see here now it shows a little red circle with the exclamation mark in there. What this means is Git has detected that we have changed the file, and that's why it's indicating to us visually that we have changed the file. If you want to know what the diff is or what the difference between the previous version and the new version is, right click on this, select the tortoise Git, and select the diff sub option. So this will bring up this window here. This is called the diff window. It shows you that the top line was changed by entering a enter after this. One more line was added, and then we added this text saying this is yet another change. Notice that Git is smart enough that it figures out that the first line was changed by just entering an enter after it, a new line after it. So that's why it highlights it in gray, saying this part is practically same. The empty part that it shows, these two lines here, lines 2 and 3 in yellow, it says these are the lines that have been entered. So let's say good, and we close that window, and now let's commit again or check in again. Then we say git commit master to check in back. As soon as you do it, this time it would not ask you about your email and so on, because you supplied that the first time and it saved it saying it was Sanji who was making these changes. It's the same person. Now let's make a note here again. We made a small change addition that was of code, and let's say okay. So the code got checked in again into the repository. Let's close this thing. It again shows the little green check mark here saying that there are no differences between the repository and the working copy. Open the file one more time, and let's this time delete this last line. Let's save it again. File, save, close the file. Again we see that Git notices there is a change and it highlights that. Let's check this change back in. So let's say git commit master, and we say here we removed a line. Actually, before we do that, let's see the diff. So we look at tortoise Git and then the diff. So here this time, see, it highlights in this brownish color that we are removing this one. Remember, when we added something, the addition is showed in yellow. When we remove something, it is shown in this brownish color. Okay, so let's check this in tortoise Git, and then commit the changes, and then we say made a change, deleted a line, say okay. It said successful, and then we close this. At this point of time, you can actually right click on this file, select tortoise Git, and say show log. Show log will show you all the changes that have been made to this file so far. So here this is a visual representation. You can see this is the very first. Actually, if we expand this date field here, it says at 4:30 I made the first change. I added it, shows it by this little add icon. It says and the message that I sent was I am testing it. This is my first check-in, and the file is shown here. If you double click this file, it will show you this is how the file looked like in the initial check-in, in the initial entry into the source control system. Then you can see that there is a highlight here. It shows that in the second one, it shows that there is a change, and if you double click this file here again, it will show you that there was an addition here of some text. If you look at the last one, it says made a change and deleted a line. Double click it and it will show you that in the brown color some code has been removed, some text has been removed. So this is how the Git source control works in its most simple form. You can be quite happy with just this much and it would solve most of your scenarios, but there are a few issues with this approach. First of all, if we close this, remember that when we initially started the repository, it said that it's creating a directory by the name .git in the same directory. So the problem is that the repository is indeed stored in the same directory as the working copy. This would make me a bit nervous because the working copy and the repositories indeed are in the same directory. And what if by some chance I accidentally deleted the whole directory? In that case, I would lose the entire source control data, all my changes. So that would be kind of bad. We don't want that. So let's move on to the next topic on how we can keep the source control data out of the same directory. A better way to do this or to manage repositories outside the working copy is to create what is called as bare repositories. Now you can see the original model that you have a repository and then you have the working copy. Conceptually, these are two separate entities. However, when working with Git, the repository is held within the working copy as a hidden directory, which makes us a little bit nervous. So let's look at the other model that Git provides. So the Git model is, as I already said, using something called bare repositories. Now, a bare repository is a repository that is not associated with any working copies. So here on the screen, you can see this thing called bare repository. Now, this is a repository indeed, but you should not make any changes here. If you try to make changes here, Git system is going to complain that you are trying to make changes to a bare repository. So what you do is that you should never be changing this one. It's a pure repository. It should never be changed directly, but only through Git tools. Once you have established a bare repository, there are some other terminologies that we should go through before we continue. Now, when you want to check out a copy from a bare repository, a working copy from bare repository, it is called cloning. So here you can see in step 1 here, we clone the bare repository and we create a working copy out of it. Now, cloning is slightly different than just checking out a working copy. What you end up doing when you clone a bare repository is you check out a working copy, but you also check out what is called as a local repository, a copy of the entire repository along with your working copy. So your working copy and your local repositories exist side by side, just as we had seen previously. If you go back to the previous slide, you can see there's a working copy here and there's a repository here, and we are checking out stuff and we are committing back in to the repository. Here in the same model, if you do the same thing, then you would see within this big black circle here, you can do the exact same thing. You have a working copy and you have a repository corresponding to it, and you can check in stuff here to your heart's content. The only difference here is that in step 1, from a bare repository, you created a clone of the bare repository, which becomes your working directory. You can do the same thing. You can create another working copy here. In the lower part of the screen, you can see there is another working copy. It also has its own local repository, its own working copy, and so on. In both these cases, once you have cloned a bare repository, you make all changes to the working copy, and if you want to check in any changes, you do them to the repository associated with the working copy. The repository associated with your working copy gives you all the benefits of source control that we have talked about. However, if after checking in or committing one or more changes, you are quite comfortable with the code and want to put it in the more safe bare repository, because the bare repository in this case will exist somewhere else. It will be on the disk in a different directory. Your working copy and the local repository will be in the same directory. So yeah, so going back, if you are more comfortable with now, after committing your changes locally to the local repository, if you're comfortable enough with the code that you want to put it back in the bare repository, then you have to start this process called push. So you push your data back to the repository. So that is what the step 6 here says. You can push the data back to the repository. Now, being able to keep your repository in a different directory is not the only benefit by using a bare repository. The other important thing to note is there is no restriction on how many working copies you can have checked out at one point of time. You can in fact have as many working copies checked out as you want. Since you only communicate with the bare repository when you are pushing changes, you can use the full benefit of source control with every single checked out copy. And if you want to keep the changes in the longer term, you push them to the bare repository. So now let's look at how to use bare repositories. So let's go back to our directory here, code directory, and delete this thing. Delete, and let's create a folder here called code back again. And let me now create a directory here called bare repository. Let's go in there and we say git create repository here. Remember last time I said that ignore the make it bare checkbox. This time let's select it and we say create a bare repository. Here you can see that it says make it bare, no working directories. So that's back to the fundamental. Do not make any changes in this directory manually, only through git tools. So let's say OK here. So it says initialize empty git repository in C code bare repository. That's all well and good. So now let's go back to code, and this bare repository has been created. Let's create a directory here called test1 and another directory here called test2. We are going to check out 2 copies of this bare repository that we have created. Go back to test1 and here we'll say this time git clone. So when we try to clone, it asks where do we want to clone from. So hit the dir button and then let's go to computer and then C colon and then code, and this is our repository, so we'll select that one. We say bare repository and we want to clone it, and let's say OK here. So it says done, warning, you appear to have cloned an empty repository, which is well and good because we just created an empty repository. You can see that here we created the repository, the same directory again, bare repository, and it has no content in. Let's go ahead and do the same thing for the other one too. We say git clone, and then the same thing, hit OK, and it says you have done empty, you have cloned the empty directory. Go back to test1. It shows the little checkbox icon saying the repository is there are no changes whatsoever. Go back in and let's add a text file here, new, and let's say text document, and this one is called test1, and let's put some content in there called this is a test in bare repository functionality. File, save, and close this thing. Now right click this one, select tortoise git, hit add, select everything and say OK. It brings in the commit dialog, and let's say commit, and again since we had deleted the previous directory, it will ask us for the username and email. Let's set these things. Hit apply, OK, and it brings in the message to be entered. So test1, entering file in bare repository, and hit OK. And at this point of time, you see the option push. So this will actually make it part of the bare repository. So let's say we want to push it. We want to make this change permanent. So it will bring in a dialog box, and you can ignore pretty much everything and just hit OK. So it says success. It has pushed all the changes, and it says also to where. It says I have sent all the changes in to C code bare repository. Let's close this. Now let's go to the other repository. So we had test1 and test2, two directories, right? And we had cloned the bare repository in both the places. So to get the changes over here, we will initiate this process called pull. So the way it works is, if we look back at our little diagram, so we had the working copy, and then from the working copy, we committed locally to the local repository. Then we wanted to push the changes over to the bare repository. So we initiated the process called push, and it pushed the data over to the bare repository. Now from a different location, if we want the data that has been changed and sent over to the bare repository, then we have to initiate this process called pull. So you can see here the number 5 arrow is pull. In this case, we'll apply the number 5 arrow on the second working copy, and we'll pull all the changes from the other repository over here. So let's look here. Now we are here in the second one. Go in here, and you can see this folder is right now empty, even though we have pushed all the changes over to the bare repository. So let's go back and right click, and we say tortoise git and say pull. At this point of time, it will bring in the dialog saying this is where you want to pull from. Don't worry about anything else, just hit OK. And it will say pull. It will say pull data from the bare repository. Close this, go in here, and you see that the file that we checked in at the other point in the other one in test1 directory has reached over here. So this is the second model of working with Git, where you have one bare repository and you have multiple working copies. So going back, bare repository directory here is the bare repository, test1 and test2 are working copies. Both these working copies have a local copy of the whole repository in them, and you can commit locally. Only when you need to make the changes permanent, or you want to send them over outside to the main directory, that's when you right click and say push. Whenever you want the changes back in, you right click and say pull. Now this brings in the interesting topic of what happens when you have multiple working copies and you make changes in one of the working copies, committed, and push the changes to the bare repository. And now you want those changes on a different working copy, and you ran a pull. And the problem that happened was during pull, the system figured out that you made a change in your local copy, and unfortunately in another working copy, either you or someone else also made a change in the same file at nearly the same place. Now the system gets confused. The Git tool cannot really figure out which changes should actually go in. It will show you that the first change has happened, and then it will also show you the second change has happened, and the fact that it cannot automatically figure out which change should go in. This is what is called as a conflict, a merge conflict. The system tries to merge the two changes and finds that whatever heuristics or algorithm it is using to merge those changes cannot automatically resolve this thing. So it will prompt you at that point of time saying, oh, I have an issue, and can you please take care of this thing manually? Now let's look at how a merge conflict can happen and how we would resolve it. So let's now make some changes in nearly the same locations in the two files and see what happens. So let's go in the first working copy, test1, and let's make a change to this file, and let's remove this word functionality here, and let's call it this is a test in bare repository. We are trying something. We deleted one word and we added a whole sentence. Let's save this thing, and let's push this. And let's say tortoise get and commit here first. So okay, we made a change that should conflict. Okay, and let's push this change, hit OK, and the change gets pushed. Now let's go to test 2, and at this point of time we are in. Let's make the change here, and we say this is a test in bare repository functionality. We are trying something else in here. So this is the second copy, and we made a different change here. Let's save this thing, and let's commit this. And this is the first time we are trying to commit something, so it's asking us for the username and so on. Let's add those things. And we added a different change and hit OK. Now the dialog has come in again, wants to push. Let's see what happens if we try to push. Let's hit push and hit OK. And you see this error message saying Git did not exit cleanly. And then it says updates were rejected because the tip of your current branch is behind. So what happened is, now you try to make a change and it cannot figure out. It says its remote counterpart merged the remote changes before pushing again. So this time you made a change, the system could not automatically figure out how to merge the changes, so it's complaining. Let's close this. The way to fix this is you go back to your repository, right click, and first make sure you pull all the changes. So let's say we pull all the changes here, and it again says merge conflicts exist here, right? Then it says automatic merge failed, fix conflicts, and then commit the result. Okay, so let's close this, and then Git will bring a little dialog saying, do you want to see the changes? And you say okay, let's see, and it brings in again another window, and it says there is a conflict so and so. So let's double click this thing, and it will show us that these are the changes, and it doesn't know, like, it's showing you that the same line has been changed on both the sides, and it doesn't know how to resolve this. So automatic resolve has failed. So let's close this window, close this window as well, and you see a little triangular icon here, the yellow triangular icon with exclamation mark, this saying that there is a merge conflict. Go in there, and it shows that test 1 has some problem. So let's double click test 1, and you will see that there's arrows going one way, it says head, and then arrows going the other way with some random characters here, and then there's a line in between. So it's saying I don't know whether to take this portion or whether to take this portion. So at this point of time, you will have to apply whatever resolution logic you have to apply manually. So let's say I am smart, I am the boss on this project, and I know that the text should look a little bit different. So I delete this part here, and then I will delete this part here also, then I delete this part also here. So all I should leave in this file is exactly what the end result should be. So now I have the two lines here, and I see that they are almost the same. It's just that in the end I say else in here and something here. So I would like to put something else, let's say, or maybe I want to accept else in here. So let's delete my file, my line, and now let's save this thing, file, save, and then close this thing. And now it shows that this thing is now resolved. You accepted the changes that came in. You could have tried something else, in which case if you, let's say, entered some change that was different from what came in and what you put in, you could have right clicked and said tortoise git, and then you could have used, there should be this button saying resolve. So that is another way to resolve this situation. So whenever you are pushing or pulling, you should always make sure that you resolve all changes before you check in anything. Now, since we have resolved a conflict, the last piece or the summary that I'm going to give out is the way to work with a bare repository and multiple working copies is to follow the following principle. Step 1, create a bare repository. Step 2, clone one or more working copies from it. Step 3, commit locally to your local repository. And then if you have multiple working copies and you're making changes in more than once, then before you push any data to the bare repository, you should pull all the changes from the bare repository to the working copy, resolve any merge conflicts, and then push the changes to the bare repository. This is the end of my lesson on Git. Git is much more powerful than what I showcased above, but going over all of Git is way beyond the scope of this course. You should research the internet for how else you can use Git and what else it offers. Alright, goodbye and see you at the next lesson.